No, in this video, we're going to start looking at chapter 1.2, sampling from a population. So we're going to look at the sample versus a population. What exactly is statistical inference? Sampling bias, looking at simple random sample, other sampling techniques, and lastly, other sources of bias. And we'll tackle all these topics in 2 to 3 videos. I'll pretend you didn't see that. Okay, as a review, say I want to know what percentage of people are vegetarian. The cases are people. The measured variable is what? Categorical or quantitative? Now, I go over this question because, in my experience, some students might think it's quantitative because you're trying to figure out a percentage, and a percentage is a number. But what are you asking the people, the cases? You're asking them, are you a vegetarian or not? And that question is categorical. It is a categorical variable. Right. Oh, actually, before we go on, I want to do a quick reminder. A lot of times when you have a categorical variable, that leads to questions that involve percentages or proportions. So a lot of times, if you're trying to find a percentage or proportion, that comes from a categorical variable. Okay, so I got a couple definitions right here. A population includes all individuals or objects of interest. Now, this is a very vague, general definition, and it's on purpose, because this population could be whatever you're interested in studying. It could be, all college students. It could be all college students at SRGC. It could be all U.S. adults. It could be all U.S. adults that are voting. It could be all adults in the world. It could be every redwood tree on the planet. It could be every single pug in the United States. Really, the population could be anything you want it to be. Just what are you interested in answering questions about? A sample is all the cases that we have collected data on. So a sample is going to be a small subset of the population. And statistical inference is the process of using data from a sample to gain information about the population. All right, this is huge because we're going to spend most of this class talking about discussing, looking at the power of statistical inference and the drawbacks, limitations of statistical inference. But it's that process of using data from a sample to get information about the population. In fact, I want to go to a picture. I'm going to put this picture on slides and draw this picture many times throughout the semester. Looking at statistical inference, say we have a population, and I like the graphic here as a cloud. I don't know why it's green, but we've got a green cloud, because a population, in some ways, oftentimes is very big, and it's changing. If we're looking at all U.S. adults, do we count people that are 17 that are just going to turn 18? What about all the people, sadly, that are going to pass away today or tomorrow or this week? Population is changing. So I think of it as like a cloud. Population is like a cloud. It's big and it's changing. It's not exact. Whereas we're going to take a sample from this cloud. This sample is going to be much, much smaller, and it's something we could analyze. We can get information on. So that sampling comes, we take a population, get a very small sample, and statistical inference is then the information from the small sample, what can we then say about this entire population? All right, this is a fairly famous photo. If you're not aware of this, this is President Harry S. Truman. He was running for re-election, and here he is. He going against Dewey. This is after World War II. And the Chicago Tribune printed this in the morning of the election. Dewey defeats Truman. And here's Truman posing with this picture because he won. Truman won the election despite this paper kind of having an egg on their face saying Dewey defeated Truman. So what happened? Okay, so the paper, the Chicago Tribune, published before the conclusion of the 1948 presidential election. And it was based on the results of a large telephone poll, which showed Dewey sweeping Truman. As I just mentioned, Truman won the election despite this poll. So what went wrong? All right, this is very interesting because this is eventually studied. This was a long time ago. And what happened is there's nothing wrong with their polling. They actually did a good random polling, but they only called people. And in 1948, not everyone had a telephone poll. And in fact, if you look at the population that were wealthier, middle class, and up, that part of the population did vote for Dewey. But the population that did not have a telephone, or not part of the poll, ended up voting much more for Harry Truman. So there's nothing wrong with the poll and their questions, but they did not get a representative sample of the population. And we call that sampling bias, when the method of selecting a sample causes the sample to differ from the population in some relevant way. So you completely miss out on a big section of the population in your sample. Your sample is going to be biased. If sampling bias exists, we cannot trust generalizations from the sample to the population. All right, so going back to that picture, we have this population. It's a Technicolor cloud, and we want to get a sample that roughly looks like the cloud. So notice here it's mostly reddish, so the sample should be mostly reddish, but there's some blue and green, so there should be some blue and green in the sample. This would be a good sample because it roughly looks like the population. Whereas we got a sample here that say was all red, that would be a bad sample. And this is what happened with the Chicago Tribune. When they only did a telephone poll, they only happened to get upper middle class and wealthy constituents in their poll, thereby missing out on a big chunk of the population that voted for Truman. And we're going to come back to this idea in Chapter 3. How do we simulate samples? The idea here in Chapter 1 is we want to make sure that sample is similar to the population, just smaller and more manageable. Okay, so actually this next activity, I'm going to skip this for right now. We're going to go through this Gettysburg Address on the first day of class. So we'll come back to this. All right, so we're going to come back to this, but the idea is taking a random sample. So I'm going to skip this because I'm going to focus on the random sampling in class on Wednesday, or excuse me, our first day of class. But the idea of a random sample is that everybody in the population has equal chance of being selected. In fact, I'm going to write that down. I'm going to select somewhere. Excuse me. So a random sample means that every case in the population has an equal chance of being selected. Oops. All right, that's what I mean by a random sample. You're not going to miss out. Think about the Dewey versus Truman poll. The problem with that is if you didn't have a telephone, you had no chance of being selected in 1948. Okay, so equal chance of being selected. That's what we mean by a random sample. And random samples have averages that tend to be centered on the correct number. Non-random samples may suffer from the sampling bias. And we only want to focus on random samples. If you don't have a random sample, then generally the results are not going to generalize to the greater population. All right, and another analogy or visual thing about this, if we're tasting a bowl of soup, population might be the entire bowl of soup, sample is in your spoon, or whatever you're eating. And if you take bites non-randomly, if you go through here and try to get a whole bunch of meat and no broth, it's not going to be like the soup. You stab with a fork, you might not get an accurate representation of the soup. So how do you get a representation? You stir up the soup and just randomly throw the spoon in there and take a scoop. Hopefully that scoop is a good random and representative sample. Okay, so a simple random sample, each unit of the population has the same chance of being selected. That's what I just wrote down. And regardless of other units chosen in the sample. So let me go back here. A lot of sampling is done via technology. So if you have, say you want to do a simple random sample of 25 SRJC students, we could go through admissions and have them randomly select 25 students. Just have a computer randomly select 25 student ID numbers, and that would be our sample. So all 20 plus thousand students have a shot at getting in the sample, and it's being randomly selected. Okay, I want to go through just a little bit more detail than what's in the book. There's something called systematic sampling. It's a method of selecting a random sample by first ordering the members of the population, then choosing every kth individual in the list, and starting with one randomly chosen. So imagine put everyone in a line. This would probably be done on a computer, but it helps to visualize everyone's in a line, and you're going to take every third. So start with 4th, 7th, 10th, 13th, and so on. So just a different way of getting it to be a more random sample. There's something called cluster sampling. The method for selecting a random sample by dividing the population into groups or clusters, then use simple random sampling to select a set of clusters as a sample. An example of this, let's say a ranger divides a forest into 12 sectors of roughly the same size, and then uses simple random sampling and rolls the dice or something like that to select 3 of these sectors. And she then counts all the trees in each sector to estimate the number of trees in the forest. So get an idea of how many trees are in this forest, split it up into 12 sectors, but then only randomly pick 3 of those sectors, and then check the entire sector. That's called cluster. So the sample will be one or more of an entire cluster, a subgroup of the population. We have stratified sampling. Is a method for selecting a random sample to ensure that subgroups of the population are represented adequately. So you divide the population into groups, use simple random sampling to identify proportionate numbers of individuals from each group. So this is very often done in political polling. We have a presidential election coming up in about a year and a half. Stratified sampling will be used all over the place. You'll probably see a lot of samples of 2,000. And stratified means that they're trying to make sure they get every single subgroup of American voters. You break it up on race, religion, age group, socioeconomic level, gender, political affiliation, and so on. As a non-political example, suppose Alejandra wants to compare prices at 2 grocery stores, Safeway and Food Max. She can randomly select 4 items from 20 categories of groceries. So cleaning supplies, produce, meat, dairy, for a total of 40 items, and write down the prices at each grocery store on the same day. So to make sure she doesn't go in and only check, say, the meat, maybe Food Max is much cheaper in terms of their meat, but not in terms of their produce. Make sure that they get a couple of produce items, meat items, dairy items, and so on. So that would be stratified to make sure you get all the different subpopulations.